Welcome to Pawan Studies.
Hello students, welcome to physical science class. Today we will discuss about heat, which is a first chapter in physical science of 10th class. Before entering the main topic, we will discuss about a small activity. Take a metal piece and a wooden piece. Now both kept in a fridge for 15 minutes. After 15 minutes, remove both of them from your fridge and touch both of them with your hands. After touching, what do you feel? Yes, you feel cold. Why? This is simply because the heat energy will flow out of our body when we touch metal piece or wooden piece, which are colder. So we feel coldness. Similarly, when we touch hot substances like tea and any hot substances, the heat energy will flow from the tea or hot substances from our body, so we feel hot. Here in this activity, in both metal piece and wooden piece feel colder, but which of them feel more colder? Yes, it is metal piece. Why? Because when we touch metal piece, more heat energy will flow out of our body when compared to the when we touch the wooden piece. So we feel metal piece will be more colder rather than wooden piece. Now we will discuss about the term temperature. What is meant by temperature? I think you are all discuss about temperature and you are all listen about temperature. That means my body temperature is your body temperature, atmospheric temperature, etc. But what is meant by temperature? I will tell about the conventional definition of the temperature. It is the degree of hotness or coldness of a body is called temperature. The degree of hotness or coldness of a body is called temperature. Now we will discuss about a thermal contact and thermal equilibrium. The two bodies, when the two bodies are in thermal contact, the heat energy will flow out from the hotter body to colder body till both get same heat energy, that means same hotness or same coldness. Like for example, my body will be in thermal contact when I did not feel heat or cold. But when I feel hot, I loses heat energy. I gains heat energy. When I feel cold, I loses heat energy, so I feel cold. And here, thermal equilibrium means the state of a body in which neither receives nor gains heat energy is called thermal equilibrium. Now we will discuss about a small activity. Take two glass tumblers, one is filled with hot water and the other is filled with cold water. Now take a laboratory thermometer which contains mercury. Now place the thermometer in hot water and then cold water with same thermometer. What do you observe? In first case, when the thermometer is in hot water, the level of the thermometer mercury level will be increased rapidly, and when we touch this thermometer in cold water, the level of the thermometer mercury will be decreased rapidly. Why? In the first case, the heat energy will flows out from the hotter body, that means hot water to colder body mercury level to mercury. That means mercury level increases rapidly because it gains heat energy. And in the second case, the mercury level temperature is high when compared to the cold water. So we know that heat flows from higher body to colder body. Here the heat will flow from hotter body, that means mercury, to colder body, that means cold water. So it decreases rapidly. Here we observe that the temperature is a measure of thermal equilibrium of mercury level. Understand? Now we will discuss about heat. By this activity, we conclude that heat is a energy in transit that flows from the body at higher temperature to the body at colder temperature. And the SI unit of heat is, what is one? The SI unit of heat is joule, and the SI unit of heat is joule, and Celsius or unit is calorie, and 1 joule is equal to 4.186 calories. What is meant by calorie? The energy required to rise the temperature of 1 gram of substance by 1 degree centigrade is called calorie. And the SI unit of temperature is Kelvin, and sometimes it may also express in degrees Celsius. Understand? Now we discuss about a small activity. Take two bowls. Two bowls is filled with, one is filled with hot water and another is filled with cold water. Now gently sprinkle a food color or KFNO4 solution in both of them. What do you observe in both cases? Yes, in both the cases, there is a motion of food color or KMNO4 solution, but more motion will be appears in the water contained. Water is hot water because the temperature is directly proportional to the heat observed. Here, the motion will be high in hot water. From this, we conclude that the average kinetic energy of the body is directly proportional to the heat observed. And what is meant by absolute temperature? The temperature which is measured in the Kelvin scale is called absolute temperature. Now, we will discuss about another activity. Take a glass jar and fill it with water and later hot water and later fill with kerosene or oil. Notice that there is no disturbance in water. Slowly pour kerosene or oil. That means it will be float on the water. Now keep a two-hole lid for this glass jar. Now place one thermometer from one hole which attaches to the hot water and keep the another thermometer with touching the oil or kerosene. What do you observe? In first thermometer, which is thermal contact with hot water, will be decreases, and in the second thermometer, which is in the oil, the level will be increases. Why? As we know that heat travels from higher body to colder body. Here, hot water is higher temperature when compared to the kerosene or oil. So it will be flows from water to kerosene till both get equal temperature. That means thermal equilibrium. Now we will discuss about differences between heat and temperature. Heat is an energy on the floor that flows from higher body to colder body, whereas the temperature is the quantity that determines which body is hotter and which is colder. And another differences between them is heat is the energy that flows, whereas the temperature is the direction of the heat flow. Understand? Now we will discuss about a small activity to find specific heat, to know about specific heat. Take a large glass tumbler and pour some water and heat it up to 80 degrees Celsius. Now take two identity test tubes. One is filled with 50 gram of water and another is filled with 50 gram of oil. Now clamp it with a guitar stand and place it as shown in the figure. Now keep it in water of 80 degrees Celsius for a few minutes. After a few minutes, measure the temperature of both and you will notice that the temperature in oil is more when compared to the temperature of the water. Why? Because temperature depends upon the nature of the substance. It is proved by this activity. Understand? Now we will discuss about another activity. take two glass jars of same volume and take 250 gram of water in one tumbler and 1 kg of water in another tumbler. Now heat it both up to 60 degrees Celsius. Now notice the time, how much it will reach us to get 60 degrees of both tumblers. You will notice that the tumbler which contains less water, that is 250 gram of water, will be heat rapidly when compared to the 1 kg of water contains, and 1 kg of water will be heat slowly. By this we can conclude that the rise of the temperature is depend upon the mass. That means heat absorbed is directly proportional to temperature. Heat is directly proportional to mass. Suppose assume heat is equal to Q and mass is equal to M. That means Q is directly proportional to M. And now discuss about another activity. Take 2 glass tumblers and fill it with water in both and heat it. You will observe that, but you need to take same amount of water and same amount of water in this volume. You will observe that both get rise in temperature for same and equal time. Understand? By this we can conclude that heat is directly proportional to temperature. Temperature rise of a substance is directly proportional to the heat absorbed. That means Q is directly proportional to T. From 1 and 2 activities, Q is directly proportional to delta T and mass. Q is equal to ms delta T, where S is a constant and this constant is called specific heat. To find the specific heat, the formula is S is equal to Q by M delta T. What is meant by specific heat? Specific heat is the amount of energy required to rise the temperature of one unit mass of a substance by 1 degree centigrade is called specific heat. The SI unit of specific heat is joule by calorie degree centigrade, kilocalorie degree centigrade. Serial system of specific heat is calorie by gram degree Celsius. Understand? The molecules of a system contains different forms of energy like linear kinetic energy, rotational kinetic energy, vibrational energy and potential energy. But most of the energy utilizes to increase the linear kinetic energy. Temperature rise of a substance is small. That means if linear kinetic energy will be increases, then the rise of the temperature will also increases. Now we will discuss about the method of mixtures of principle. When it is said that when 2 or more substances are in thermal contact, the net heat lost by the colder substance, the net heat lost by the hotter substance is equal to the net heat gained by the colder substances. That means heat lost is equal to heat gained. Understand? Now later we will discuss about this lab activity to prove it also. Now we will discuss about role of specific heat and applications of specific heat. The application of specific heat, first one is atmospheric temperature, balancing of temperature. Sun delivers a large amount of heat energy to the earth daily, but most of the energy is absorbed by the water bodies in the earth such as oceans. As we know, the specific heat of water is so high, that means it can not be rise to temperature rapidly. Understand? So when sun delivers a large energy, the oceans absorb this and they do not rise most temperature, and the winds that will come from the oceans to the land, which means it will be cool the land also. This is the first role of the specific heat. And the second one is when we keep freeze watermelon for a period of time, and after removing it, it will be retained in coolness for a long time, because watermelon contains most of the water molecules. As we know, specific heat of water is high, so it does not loses heat quickly, so it will be remain cold for a long time. And third one is, as you know, samosa. The outer layer of samosa will be cool after some time, but when we eat, we feel hotness. Why? Because the ingredients which are in samosa having high specific heat. As we know that if specific heat is high, it does not gain heat energy quickly or loses heat energy quickly. So it does not lose heat energy quickly, so it will be retain hotness for a long time. Understand? Now we will discuss about evaporation. What is meant by evaporation? In simple words, the phase change of liquid to gas at a neat temperature, it is called evaporation. But we are 10th class, so we need some high definition. That is, the definition of evaporation for us is the escaping of molecules from the surface of a liquid at any temperature is called evaporation, and evaporation is a cooling process. Because, for example, to prove this, when we get sweat, after we will be stand near the fan, we will be cool. That means the water in our body will be evaporates. As evaporates is a cooling process, our body will become cool. Another example is dark tan during hot summer days. Dogs does not have sweat pores because it will be loses water from its tongue to become coolness due to evaporation. Now we will know about the factors influencing in the evaporation. The factors influencing evaporation is surface area, humidity, temperature, velocity of air. First, we will prove surface area. Take a water in a cup and saucer with same volumes of water. Now, which one will be evaporates faster when it kept under the fan? It means saucer. In saucer, the surface area is larger than cup, so the water in the saucer will be evaporates faster when compared to the tea. So, surface area is a factor influencing the evaporation. Another factor is temperature. In hot summer days, the wet cloths will dry faster when compared to the drying of wet cloths in rainy season or winter season. In winter season, temperature is cold when compared to the summer season. So, due to the temperature, the wet cloths dry faster in summer when compared to the winter. So, temperature is a factor influencing evaporation. And third one is humidity. It is inversely proportional. That means if in rainy day there is more humidity in atmosphere when compared to the summer. So the wet cloths will be dry slower in rainy season when compared to the summer season because of humidity. So we can conclude that humidity is also influenced as a factor in evaporation. And last and final fourth factor of evaporation is velocity of air. In high velocity air days, the wet cloths dry faster when compared to the low velocity air. But if you want more example, refer to our textbook. And now we will discuss about condensation. What is meant by condensation? The phase change of a vapor to liquid at a constant temperature is called condensation. Condensation is a warming process. And we will discuss about boiling. What is meant by boiling? It is similar to evaporation, but it will be in a constant temperature. That means boiling means the phase change of liquid to gas as evaporation, but evaporation will be at any temperature, whereas the boiling is at constant temperature. That means boiling means phase change of liquid to gas at a constant temperature is called boiling, and evaporation is a cooling process, but boiling is not a cooling process. Remember this. And the factors influencing in boiling is pressure, but it is not a evaporation factors. Understand?
Boiling point of water is 100 degrees Celsius or 373 degree Kelvin. Now we will discuss about humidity. What is meant by humidity? Humidity is the amount of water vapor present in the air is called humidity, which is a factor in evaporation also, as we discussed in earlier. Now we will discuss about dew. In early morning during winter, you will observe that water droplets form on window panes, flowers, grass, etc. During winter, the atmosphere temperature decreases and the surface of window panes, flower, grass becomes still colder. The air near becomes saturated with water vapor and condensation begins. Then the water droplets condensed on such surfaces are known as dew. It is dew. Now we will discuss about fog. In winter, if the temperature falls further, the whole atmosphere in that region contains a large amount of water vapor. And now the water molecules present in vapor condense on the dust particles in air and form small droplets of water. These droplets keep floating in the air and form a thick mist which restricts our visibility, which is called fog. The thick mist is called fog. Now we will discuss about latent heat of vaporization. The heat energy is used to change the state of water from liquid to gas at a constant temperature is called latent heat of vaporization, that is equal to Q by M. Latent heat of vaporization is denoted by capital L, and the CGS unit of latent heat of vaporization is calorie by gram and SI unit is joule by kg. Heat of vaporization of water is 540 calorie by gram. Now we will discuss about latent heat of fusion. The heat energy required to convert 1 gram of solid completely into liquid at a constant temperature is called latent heat of fusion. The heat required to change 1 gram of solid into liquid is Q by M, and latent heat of fusion of ice is 80 calorie by gram. Now we will discuss about melting. The phase change of solid to liquid at a constant temperature is called melting. Now we will discuss about freezing. The phase change of liquid to solid at a constant temperature is called freezing. It is a quite opposite to the melting. During melting, the volume of a liquid will be increases. To prove this, we have one activity also. Fill the water bottle full of with water and keep it in a fridge overnight and see it in early morning. We will observe that the bottle will be broken and the level of the water will be increases while it turn into solid ice. So we can conclude that due to the freezing, the volume of a liquid will be increases.
Thanks for watching. Bye bye.